Okay, let us continue. Experiment number 6. So we will perform experiment number 6 today, which is the small signal amplifier. So from the previous experiment, which is experiment 5, we just noticed the DC analysis for the amplifier, for the BJT. This time, we will consider now the AC analysis, which is the small signal amplifier. Objectives. Activity aims to present the basic configuration and functions of a small signal amplifier. Intended learning outcomes. The student should be able to examine the amplifier concept and its circuit construction. Interpret on the response of common emitter amplifier, common base amplifier, and common collector amplifier. From the previous topic in our live lecture, we discussed about the different configurations of an amplifier, which is the common emitter, common collector, and common base. And we have this table in our lecture. So we will use multisim to verify these values. So some of these values, we cannot measure the input and output resistance using multisim. We can measure, but in this experiment, this is not covered in this experiment, measuring the power gain, the input resistance, and the output resistance. We will just measure the voltage gain, input and output voltage gain for this experiment. Okay, the first activity is using connecting a common emitter amplifier. Activity 2 is common collector amplifier, and activity 3 is common base amplifier. Let's start with the connection of the circuit using, this one is using the NILBs, but we will connect this one in multisim. So we will connect this one. So we need 10 volt supply, R1 100 kilo ohms, R2 20 kilo ohms, R4 4.3 kilo ohms, R3 is 1 kilo ohms. Then we have 1 microfarad, 1 microfarad, and 10 microfarad capacitors. We need also to measure the BCE, and we need to measure the output voltage and input voltage using the oscilloscope. And we need an input signal, which is the function generator. This one. So let's start the connection. Using multisim. This one. We need a blank page, blank design for the multisim. So this one. Okay, this one. So we need to connect, we need the supply, which is 10 volt supply, BCC. 10 volt supply, BCC. Ground. Ground. We need BCC, 10 volts. We need transistor, which is, yes, same, 2N2219. Then we need 100K, 20K. 100K, 20K resistors. 100 kilo ohms, 20K, 1K, and 4.3. Complete. We need capacitor, 1 microfarad, another 1 microfarad, and we need another capacitor here. Which is 10 microfarad. Microfarad. Okay. rotate, rotate, rotate. So we need to connecting this one, and we'll change this one to 100K. R2 is 20K. R4 is 4.3K. Then we have R3 1K. Let's check. 1K. So the inhibitor is 2 and 2, 2, 2, 2, 2. That's 1. Connect voltage divider. Connect RE, R2, R1, supply 10 volts. Then we need output C2. Then this one not yet connected to the ground. And this one in capacitor. Then we need a function generator, which will be our input signal. Then we need ground. Okay, then we need oscilloscope. Oscilloscope is one. We need to connect the channel A to the input. And I need to change the color. Let's say red. And the output, change the color to blue. Okay, then we need brown. Okay. And from the procedure, be sure to connect all connections. Be sure all connections are properly placed. The power supply, variable power supply, BPS set to 10 volts. Yes, it is set. And open the DMM. So we have no yet DMM. DMM is voltage across the collector and the emitter. So open down. Okay. So, then I need space. Yes. Okay. Emitter 1. Next, from the procedure, we set the supply. Yes, we set the supply 10 volts. Then we have opened the DMM. Function generator is 0.02 volts peak to peak. From the procedure, it is 0.2 volts peak to peak. But I changed this one to 10 millivolts peak, 1 kilohertz. Okay. So So that will be the settings of the function generator. Then we have procedure. Oscilloscope, 100 millivolts, 100 millivolts, 500. No, this is 10 millivolts. 10 millivolts. 10 millivolts. Later we will adjust. ECE coupling, ECE coupling. And the scale 500 microseconds. Oops. Yeah. Okay. Next, click run. Click reverse. So masyadong mataas yung output, so we need to adjust channel B. Okay, that will be the value. Then the BCE is almost half of the supply, so it is okay. So we have a good output. So this time we need to get the waveform. So we need to get the waveform, this one. So auto paste for common emitter. Recording the output, screenshot, record. So I need to input the input voltage. Our input voltage is 20 millivolts peak to peak. Okay. 20 millivolts peak to peak. Next, what will be the output? We need to measure the output. So we need to measure the output. Just the cursor to the blue, then maximum. Next, this one to minimum to get the peak to peak output. Okay, so this is channel B. The blue is the output, is channel B. The peak to peak voltage is 82.214 millivolts. So we need to record that one. So that is 82. 82.214 millivolts peak to peak. Oops. We need to solve for the voltage gain. ABS to solve. Next procedure, we need to put bypass capacitor. So the bypass capacitor, this one, C3. So when we put bypass capacitor, this one, what will happen to the output? This is the previous output. When we add bypass capacitor, the output is high. So meaning we need to increase the volts per division. So this will be the new output. It is higher than the previous measurement. So get again or screenshot for this one. This is with bypass capacitor C3. So with bypass capacitor C3, this will be the waveform. So we need again to measure the peak to peak. Cursor to the blue. Then Ymax. Next cursor red, but to measure blue. So this one, next Y min. This one. So peak to peak value for the blue is 2.178 volts. So we need to record the output, which is 2.178 volts. So we have an increase in the output. Without bypass capacitor, our voltage is only almost 82 millivolts. At this time, we have an increase in the output voltage when we put the bypass capacitor. With the same input, 20 millivolts peak to peak. So we are through with activity 1. That is common emitter configuration. It is 180-degree out of phase. Next, let us proceed with activity 2. Activity 2 is using common collector amplifier. For the common collector, let's move to the procedure. Activity 2. This one. Activity 2, common collector amplifier. So we need to connect the circuit, but we have no NILBs. We will use multisim. So this one, we will connect this one. So we need different values for R1, R2, R3. Still with 10 volts, but without RC. So meaning we need to copy paste this one. Control Alt, Control C. We need new design. Paste. Then remove all the waveforms. We need to replace this one. I think we do not need to remove this one. This one. Then removing R4. R4 must be connected directly to the collector. So this is common collector. So we have this one is not our output. Our output is this one. And we need to put this one here. This will be the output. Mas maganda pagpalitin natin. Okay. This one will be voltage across collector emitter. This one. Next, we need to change the value of R1. No. R2 is 300 kilo ohms. So this will be 300 kilo ohms. Then we have 1 kilo ohms. C1, 47, and then 470. This one is 47 nano. Then this one is 470. 470 nanofarad. And this one is connected. This is our output for common collector. I will use different color again, which is green naman tayo. We use green as output. Then we will use blue as input. So we will use blue as input, then green ang output natin. Okay. So we need to measure ECE. So almost half of the supply, so it is safe. But we do not have yet the settings for the function gen. Settings for the function gen from the procedure is so this will be the connection for the common collector. So this will be the connection for the common collector. So we will set now the function generator, which is the value should be 1 volt peak to peak. So we need to set this one as 0.5. Kasi sabi niya 1 volt peak to peak. So this is BP. Then still 1 kilohertz. Let us double check first the procedure. So the supply is 10 volts. The function gen is 1 volt peak to peak. 1 volt peak to peak. So that is 0.5 volts peak. Then the frequency is 1 kilohertz. Then for the oscilloscope, it's 1. So 500 millivolts. 500 millivolts AC coupling. And then 500 microseconds. Okay. I think this is okay. Then you need to run. Okay, run this one. Okay, almost half of the supply. Then this will be the output. So the green and the blue, almost the same waveform. They are in phase. The green and the blue. One is green, one is blue. So for you to separate the output and the input, the green is our output and blue is our input. So we need to stop and we need to measure the waveform. So we need to bring this back to 500 millivolts per division. So I need a screenshot for the output, common collector. So we have no voltage gain for common collector. Same input and output. Approximately same. So we will measure that one later. So I need to record the waveform for common base. That is common collector activity 2. Waveform. Next, we need the input voltage. The input voltage is 1 volt peak to peak. 1 volt peak to peak. Then the output is, let us measure. So what will be the output? Measure. Measure the output. So I will adjust this one. Yeah, that one. The green is our output. Then I will move the cursor blue. I need to measure the green. So I need to click the green. Okay. So peak to peak, positive peak. To move to the positive peak, Y max. Next to the Y min. Next, Y min. So the peak to peak is 0.99, 0.989 volts or 0.99. So I will record the output, which is 0.99 volts peak to peak. So you will compute for the voltage gain. So that is activity 2, common collector. Activity 2, common collector. Next, we will proceed with activity 3. So activity 3, back to procedure. So this is the data for common collector. In 1 volt peak to peak, output is 0.99 volts peak to peak. And this is the waveform. So back to procedure, common base amplifier. Activity 3, sorry. So this one. We need to connect the circuit, the input at the emitter, output at the collector. So almost the same value with common base. So we will connect this one. At this time, almost the same with common emitter. So I will just copy paste the common emitter. Common emitter, which is this one, our common emitter. And I need new design. This one. So I need to disconnect this one. Okay, let us double check the procedure. On the procedure, we have capacitor 22 microfarad, then 0.1 microfarad, and another 0.1 microfarad. R1 is 100 kilo ohms, R2 20 kilo ohms, R4 4.3 kilo ohms, R3 1 kilo ohms. 10 volt supply DC. Then we need to measure the voltage across collector emitter just to verify that it is half of the supply. So let us see. We need a function generator. So this is common base. So we need to connect the input not at the base but at the emitter. Meaning this one is connected at the emitter, then the input signal is connected to our C1. Next, this will be our output. We will use another color, green again, for our output. Then we have blue for our input. Connect this one to the ground. Change this to blue. Blue. Next, this one we have bypass capacitor C3. Okay, that's okay. So let us check the function gen. Function gen should be set to 200 millivolts peak to peak or 0.2 volts peak to peak. So we need to set 100 millivolts peak and then 1 kilohertz frequency. Then the scale, let us check that one. This is 100 volts, not 100 volts, millivolts. It should be millivolts. Okay, run. Double check the supply. Yes, it is half of the supply. Then we have the output. Our input, which is blue, the blue one. Then we need to have the same settings for the one as well. 200, 200. I think 100. Mas maganda. Ayan, 100. So this will be the waveform for the output. So our input is 200 millivolts peak to peak. So let us record that one. The input is 100 or 200 millivolts peak to peak. 200 millivolts peak to peak. So that is the same that 100 millivolts peak is the same as 200 millivolts peak to peak. So our output, let's check the output. Output is color green. This one, the output. So green, we need to measure the waveform green. So Y max, then the red one at the minimum. So the output voltage is 518.5 101. So 518 millivolts. 518 millivolts peak to peak. So that will be the output for this one. So we have a gain for this one. So let us measure this waveform, or let's have the screenshot of the waveform. So record the common base waveform. So for the common base, this will be the waveform for the common base. Common base. Then common base. Common base. Waveform. Then the output input. Okay, so the final data will be this one. Ready for the screenshot. You need the screenshot for this one. So this will be the final data. So let's start with activity 1. Activity 1, we need to measure the output voltage for the common emitter. Activity 1, this is the output waveform without high-pass capacitor. This is the waveform. The output is the blue, the input is the red. 180 degree out of phase. Next, the data for this one, the output voltage. The output voltage is 82.21 millivolts peak to peak, and the input is 20 millivolts peak to peak. To solve for the output voltage, to solve for the gain, voltage gain, V out divided by V in. That will be the gain. Next, how about if we put, okay, I bring the value, so this will be the value of the first waveform. Next, the second waveform. This is the waveform for the second. This one is putting bypass capacitor. This is with bypass capacitor. Let's mark this one with bypass capacitor. This is common emitter amplifier with bypass capacitor. This will be the waveform, and this will be the input and output voltage. Ayan. This is the waveform. Input and output. Input is the red, output is the blue, 2.18 volts peak to peak, and this is the input and output for common emitter with bypass capacitor. So, screenshot. Okay, next. Next is for the common collector, which is activity 2. Activity 2, this is our data for activity 2. And the input and output is this one. You need to solve for the voltage gain. So this will be the data for activity 2. Activity 2, experiment 6. Yeah, this one. Oh, sorry. Next, the last one, which is activity 3, common base amplifier. So our data is this one. You need to compute for AB or the voltage gain. So this will be the data for common base amplifier, the waveform. Okay, so common base amplifier, the input is 200 millivolts peak to peak, the output is 518 millivolts peak to peak. And this is the waveform for the common base amplifier. Okay, I will loop this video, or I will, you can check this one in the concluded conferences so that you can have a look for this video so that you can get the waveform for this one. Okay, thank you. So that's the end of our experiment number 6.